Welcome to 49th lecture in the course of Industrial Engineering and Operations Research. We are discussing very important topic of industrial engineering as well as operations research, and that is project evaluation and review technique. We have been discussing something about project management, and in that one technique is basically CPM, where we make a network diagram, that is critical path method. So, PERT is very similar to critical path method only, but here assessments of time are probabilistic. Okay, so we involve some probability actually. So, PERT is a project management technique where planning, scheduling, organizing, coordinating and controlling uncertain activities are done. So, here main thing is that activities are uncertain. So, therefore, we have to put something, some estimates which may be probabilistic. So, PERT is basically used for those type of projects which are new in nature, and therefore, we may not know the exact time estimates, whereas the CPM can be applied even for routine project. So, PERT is a probabilistic estimate of the randomness of project events, and unlike the deterministic CPM technique, it can also be used to predict which of the scheduled tasks are likely to slip. Okay. So, this is what that we can actually do that also, and it was introduced by the consulting firm Booz Allen and Hamilton in the 1950s, in fact something around 1959, to satisfy the demands of the US Navy Special Projects Office. So, it was used basically in US Navy for the first time. This technique was used, and let us see that what is that technique, how it is done. Okay. So, similar to CPM, that means critical path method, PERT follows 6 basic steps. First is the define the project and prepare the work breakdown structure. As I said that you have to define the project, and project has these characteristic, that project has a defined goal. Okay, there is some goal. You cannot be saying that okay, this is the thing. There should be a goal that I am doing this task, and then project has a beginning and end, and then project can be broken down into number of activities, that these activities if they are done, then project is complete. So, we have to break down the project, and then after that we have to do that develop the relationship among the activities, like which activity should be done before which activity, like that. So, we have to make a precedence diagram, decide which activities must proceed and which must follow others, and then draw the network connecting all the activities. We make a network diagram type of thing, just like in CPM. Okay. So, this is like this, and maybe like this, like this type of diagram we will make, and then you will be doing that type of thing. So, you can number the nodes also 1, 2, 3. Okay. Maybe 1, 3, 3 I can put here, and 4 can be put here then. Okay. So, assign time and cost estimates to each activity, then compute the longest time path through the network. This is called the critical path, that this is the longest path in terms of the time. Okay. That means one activity goes and then another activity goes, how much maximum time it will take. Use the network to help plan, schedule, monitor and control the project. So, main thing is here that variability in activity times. In identifying all earliest and latest times for any activity and the associated critical paths, the CPM approach has been adopted. That means other things are in the similar way. Even critical path you can find out. We can only think that time estimates are probabilistic. So, does not matter, you can always take the expected time of the event and you can make that way. So, it is assumed that all activity times are known and are fixed constants. However, in practice activity completion times vary depending on various factors. For example, say activity A requires raw materials to be procured. Suppose there is one activity that you have to procure the raw material. Its activity time is 3 weeks. That means you expect that in 3 weeks it will come. If raw material is not procured at the proper time due to some reason, the activity will be delayed. Okay. So, that means uncertainty is there. So, in practice, some activities are less prone to delays, while other activities are highly prone to delay. So, the variabilities in activity time cannot be ignored while deciding the schedule of any project. Therefore, PERT addresses this issue. PERT means program evaluation and review technique. Okay. I have already said this thing, program evaluation and review technique. Okay. Program evaluation and review technique. So, this is this one. So, what is the some difference, okay, between PERT and CPM? Just I am writing something. What is it? PERT is basically a technique using probabilistic approach. Main thing is this, and the CPM is uses deterministic approach. And orientation in PERT, mostly we say that event oriented, and this is activity oriented. This has been written, but actually now, practically nowadays CPM and PERT structure etc. everything can be same. Okay. So, role in crashing, it is said that project crashing means reducing the time of the project. So, here it is by putting more resources to some activity. So, it is said that in PERT it is somewhat limited, but in CPM it is extensive. These are not very strong distinctions. Okay. That means it depends, some researcher may say that okay, I have used in the PERT this technique or something, but just I am mentioning estimates. This is important. Estimates means in PERT usually we will have 3 time estimates of an activity. We say optimistic time, pessimistic time and most likely time. Suppose I am going from say Lucknow to Kanpur. Okay. If I am going Lucknow to Kanpur by bus, then most likely time may be 1 hour and pessimistic time may be 2 hours if there is a traffic jam etc. And if you are very lucky, then it may take 45 minutes also. So, that is called optimistic time. So, we do get 3 time estimates. This is the main distinction, and in CPM we get 1 time estimates. PERT it is focuses time, and then here it is said time, cost also, cost of activities and trade off. Again this is also I do not agree to that much, because in PERT also one can actually consider the cost etc. also. It is not that you cannot do that. Main issue is that of course in PERT we have time estimates, and here there is this one, and management of unpredictable events. Okay, and this is CPM is used for predictable events. Okay. So, anyway, you can see the related some sites where you can find some discussion, but you have to take all the discussion or any type of things with a pinch of salt, because it may be different in different sites, little bit in slightly differing viewpoint. Okay. So, anyway, that you can see that this site keydifferences.com, difference between PERT and CPM. Now, coming to that main part of that which makes that distinctly different from CPM, that here you have 3 time estimates in PERT. In PERT, a probability distribution based on 3 estimates for each activity is employed as follows. We take based on the 3 estimates of time, we fit a probability distribution. Okay. And we say that here we employ the concept of beta distribution. I am not going to tell you about beta distribution, okay, beta distribution, but if interested people who want to go in depth in mathematics part or statistics part of it, they can see that beta distribution. Okay. So, it is, if somebody asks that how do you decide that expected time etc. on which distribution it is based, then you can answer that it is based on beta distribution, just like we have other normal distribution and other type of distribution. So, beta probability distribution is there. Okay. So, what happens that we have optimistic time TO indicate by T subscript O, time and activity will take if everything goes as planned. That means you are lucky, there is no disruption. In estimating this value, there should be only a small probability, say 1 by 100, that means 0.01, that the activity time will be less than T0. So, something like 99% your job should be done, means job should take minimum this much time. That pessimistic time and activity will take assuming very unfavorable conditions. In estimating this value, there should also be only a small probability, say 1 by 100, that the activity time will be greater than Tp. So, I would say that your 99% chance is that your actual time will lie between optimistic and pessimistic time. Okay. Say for example, I am going from Kanpur to Lucknow, then I can say that between 45 and 2 hours, that means 120 minutes, I must reach Kanpur. So, that means only 1% chance should be there that it takes 121 minutes, and only 1% chance should be there that you could reach in 44 minutes also. That means if you go 100 times, only one time maybe you could reach in 44 minutes, but otherwise roughly it should be like that. Then there is a most likely estimate, most realistic estimate of the time required to complete an activity. There is one, suppose you would have been forced to do deterministic analysis type thing, then suppose you say 1 time. So, most likely that most of the time you can find out in various ways, most of the time how much time it takes, then you say it is most likely estimate. But the expected activity time Te is calculated as Te is equal to Tp plus 4 Tm plus To by 6 based on the beta distribution, we obtain that expected time. So, we say Tp plus 4 Tm plus To by 6, and so you understand that basically you can say expected time is basically a mean time. We are taking just the mean or average of the things. Only difference is that if I take simple average, I would have done Tp plus Tm plus To, Tp plus Tm plus To by 3, isn't it? I could have just added all the estimates and say that this is the average, but I am not doing that. I am giving more weightage to this one, most likely estimate. So, it is a basically weighted average. So, 4 times more weightage I am giving, and which is reasonable, because you will make estimate as per that. If you ask that how much time it takes, if somebody says okay, I keep going and it takes 1 hour, then you will give more weightage to this one. Not that you give equal weightage to do, because sometimes only that if you are very lucky, it will take maybe 45 minutes, and sometimes if you are very unlucky, then only it will take 2 hours. Some special occasion is there, somebody has done rally in between, traffic jam is there. So, most likely time is given 4 times the weight as the optimistic time and pessimistic time. The time estimates computed for each activity is used in the project network to compute all earliest and latest times. So, the project completion time is the sum of expected times for all activities on the critical path. If you ask that what is this thing, so you find out the critical path, first you find out expected time for each activity, then rest of the work becomes just like CPM. Okay. And you can find out the critical path, and if you sum all expected times on the critical path, that will be basically the project time. Okay. And we can find out the variance also to compute the dispersion or the variance of the activity completion time for each activity. Variance is basically Tp minus T0 by 6 whole square, that means becomes this one. So, something like that, or you can say standard deviation becomes Tp minus T0 divided by 6. So, that means between say something, if you consider normal distribution, so between 6 sigma, you know that pessimistic and optimistic estimates lie. Okay. That means everything is within 6 sigma. Okay. Suppose you just draw a normal distribution. So, it is, this is about 3 sigma, and this is about again 3 sigma and minus 3 sigma. So, between 6 sigma. So, ST becomes TP minus T0 by 6, that is basically the, you say, standard deviation of one activity. And then what happens that here, suppose in a critical path, if you have got variances of each activities, then the total variance will be the sum of the variances. Okay. So, that means standard deviation will follow Pythagorean type of rule. That means standard deviation, suppose two activities are joined and they have standard deviation of sigma 1 and sigma 2, then overall standard deviation will not be sigma 1 plus sigma 2, rather it will be sigma 1 square plus sigma 2 whole square, and if 3 activities are there, then sigma 3 whole square, and you take the square root of that. So, this is also very important point. Okay. Let us see that one example. Suppose compute the expected time and variance for the project. The values of TO, TM and TP are provided. TO is optimistic estimate. So, activity A, it takes 2 minute, okay, 2 minute or whatever that you need, 2 day you can say, and most likely estimate is 3, pessimistic estimate is 4. Like that for activity we have 1, 2, 3. For activity C we had optimistic time 2, most likely time 3, and pessimistic, that means if there is some delay it may become too much, that 10. So, like that. Okay. So, some activities have less variation, some more. So, expected time, how do we find out the expected time? So, for expected time you use this formula Tp plus 4Tm plus T0 by 6, and you do that type of procedure here, you get expected time for each activities. Okay. So, this is also 1, 2, this one and 3. Okay. So, this is so here pessimistic time is, say, for example 10. So, let us calculate that optimistic time is 2. So, 2 is given weightage 1, and most likely Tm is 3, but 3 4s are 12, 12 plus 10, it is this one. So, this becomes 24 and divided by 6. So, it becomes basically 4. So, you see it is coming 4. So, value is close to most likely only, although pessimistic estimate is 10, but it has less weightage. And then similarly for other cases also you calculate and you find out the expected time. It is very easy, you have to use this formula Te is equal to Tp plus 4Tm plus To by 6, and variance is equal to Tp minus To by 6 whole square. So, we have done that type of thing. That means you are taking this difference To minus this one and divided by 6. So, you variances are also given, and unit of variance will be basically day square. Okay. If it is expected time is in day, then this is square of that, but standard deviation will have same unit. So, in some activities the variance is relatively higher. Variance gives information about the degree of spread in the data, how much data is spread, how much uncertainty is there. So, now probability of project completion. The critical path analysis assisted in determining that the project completion time is 15 weeks, suppose you know that this one, and however there is a significant variation in the time estimates for several activities. Variation in activities that are on the critical path can delay the overall project completion time. So, PERT uses the variance of critical path activities to help determine the variance of the overall project. So, project variance is computed by summing variances of critical activities. So, this is important. Project variance will be sigma p square is equal to sigma project variance is equal to sigma p square, and it is summation variances of activities on critical path. Only you have to add on critical path. So, what assumptions we have implied in PERT analysis? What we do, assumptions of PERT are total project completion times follow a normal probability distribution. Okay. So, we consider that whatever estimate we are getting, they are following normal probability distribution. Activity times are statistically independent. Okay, that means they are independent of each other. So, with these assumptions, the bell-shaped normal curve can be drawn to represent the completion dates. So, suppose completion date is say 15, okay, 15 week maybe. So, you draw at 15, it will have peak, that you will be bell type of shape. This is normal distribution curve, that type of curve will come. That means you will have peak. So, that means now and then it will be varying depending on that. So, normal, so it implies that there is a 50% chance that manufacturer's project completion time will be less than 19 week. If the 19 is suppose in case 19 is the time you get based on the expected time addition, okay, on the critical path. Suppose you get 19 week. So, that means only 50% chances are that, because that number, let me make it 19 here also. If I have said 19 week, so 50% chances. But if you want to increase your chance, so naturally that you have to increase the duration, that you can say this one. 50% chances are that it will exceed 19 weeks, 50% chances are that it will be less than 19 week, like that. So, example, evaluate the project variance and standard deviation of the project. These activities has been given, and I have not made the network diagram. I assume that you can make nicely and you can do that. I am just stating, let us say the critical path is this one, start A, C, E, G, H. So, variance of project is based on the critical path. The project variance is indicated by sigma p square, and that is standard deviation variance of A 0.11, variance of C 1.78, variance of E, and then variance of G is 2.78, this is 0.11, and this is equal to 4.89. So, standard deviation of the project is basically sigma p, not the whole square, by mistake that here was whole square written, sigma p. This is square root of variance, and variance already we calculated by summing all the variances. So, it came 4.89, and you take the square root of that, and it becomes 2.21 weeks. So, 2.21 weeks is the standard deviation. Now, let us see the problem. Suppose deadline and the total project time was, I already said that it was 19 weeks. So, mean was 19 weeks. Mean was 19 weeks, and then the deadline due date of the project is 22 weeks. What is the probability that the project will be completed before the due date? So, the solution is that expected completion date of the project is 19 weeks, but somebody is asking that due date is 22 weeks. So, what is the probability that it will be completed by that time? Standard deviation is 2.21 weeks. So, standard normal equation is given by, you have to find out normalized parameter Z, and Z is that basically due date means actual value, we need 22, expected cost date of completion, that means mean, okay, something you know that how to normalize binomial distribution, x minus mu divided by sigma. That's how we used to give that estimate. So, Z is equal to x minus mu by sigma. So, 222 minus 19 divided by 2.21 is equal to 1.36. So, where Z is the number of standard deviations, the due date or target date rise from the mean expected date, that means equal to 1.3 sigma, it is that away. Okay. So, that is what that. So, that means probability that it will be complete in 19 days is 50%, because this is 50, but 1.36 standard deviation comes here. So, we make a line, this is 22 and this is equal to 1.36 standard deviation. So, that means this is added. So, this area is basically 91.31% of the total area. So, therefore, that probability comes this one. but all the time you will not be measuring area with craniometer etc. If you have planimeter, then you can actually measure that, but this is not your task. What you will do that you can see the jet table, or you can use Excel. In the Excel there is a command that is norms dist. Suppose you give 1.36 normalized value in MS Excel, then it will give automatically the probability. That means 0.913085 will be the probability. Hence, there is a probability of 91.31% that the project will be completed. Project will be completed. B was missing. B will be completed within 22 weeks or less. So, probability that the project will be completed within or less than 22 weeks is 91.31%. Now, instead of 91.31% probability, what should be the due date, deadline, so that the probability of completion of the project becomes 99%. That means this area is only 91.31%. I need to find out something which will give basically 99% area, or what is that thing I am asking, probability project will be completed. So, that means before the due date, and yeah, this is I have done. So, 99%. So, how should I find out that? So, if I now probability is given, I have to find out corresponding Z. So, in Microsoft Excel, you can use norms inverse 0.99. If you use that command, you get Z value is equal to 2.3263. That means, if Z is 2.3263, then you get basically that 99% area in that. So, using the now Z is known, so Z is equal to due date minus expected date of completion divided by sigma p, or due date is equal to expected date of completion plus Z times sigma p. Expected date was 19 and this is actually 2.3263 Z came, and this is sigma p was 2.21. So, if you do that, you get due date is equal to 24.14 weeks. So, by 24th week and fraction 1/4, that means 24.14 weeks it will be completed. That probability is 99%. Okay. So, this is how that you can make the probabilistic estimate, and this is how you can complete. And so, this I have told about the PERT. Remaining all other things are going in the similar way. That means, you have to I have not repeated that. Here also you will get float and this one, and all those type of things will be doing. And now I will be discussing the another topic in my next lecture, that will be about project crashing. That means, how to reduce the time of the project. This we will be discussing in the next class. Thank you very much for your attention.